Alright guys, so welcome on back. This time we're going to be going over actually solving quadratics. So thus far we've talked about how to foil and create a quadratic, and we've graphed them and whatnot. Now we're going to actually solve them. This is where we're going to get some answer that says x equals some numbers, right? And this could be a bunch of numbers. There are a couple of things I want you to know about quadratics. So a quadratic is defined by that x squared, right? Quadratic is defined by that x squared. And you guys already used that. I told you this results in that parabola that we get, that u or upside down u. Okay? And because it's defined as x squared, the thing is you can have as many solutions or answers. So you can think of these as solutions or answers. So x equals some numbers. You can have as many solutions as the highest degree of your function. As the highest degree of your function. So for a given parabola, what you have is that ax squared plus bx plus c. And the thing that I want to highlight here is that x squared. So because we have our highest degree of 2, you can have as many as 2 real solutions. So you can have either 2 real solutions, 1 real solution, or 0 real solutions. Okay? All these are very possible, and we may end up with different answers. Actually, let me go ahead and do all 3 of these. That way you have an example of what I mean by real and fake. Or, I'm sorry, real and non-real solutions. They're not fake, they're just called non-real. Okay, so this would be a situation where you have 2 reals, and actually this is going to help us with using graphing to answer these questions. So if you have a situation with 2 reals, all right, you're going to have a graph. And then I have a parabola, and it looks like this. It crosses the x-axis here and here. Every time it crosses the x-axis, that is one of your solutions. So if I told you that this point was positive 1 and this point was negative 1, your 2 real solutions would be positive 1 and negative 1. Alright, so your solutions are where your graph crosses your x-axis. Now, if I have just one real solution, so we'll do this one in green. Alright, again, I'll just go ahead and graph. And this would be a situation where your parabola only touches the x-axis once. So basically your vertex would touch that x-axis. Okay? And again, this could be at 1. So your one real solution here, let me get that all on screen. Your one real solution here would be at positive 1. Alright, so 2 reals, it'll cross the x-axis twice. 1 real, it'll cross the x-axis once. And then here is, let me see, I use blue, I use green, here's brown. This is 0 real solutions. Alright, 0 real solutions. And with 0 real solutions, it'll look something like this. Another graph like that, and then it'll do something like this. Here's your vertex, and it'll just go down. And you'll notice here that it's never going to cross the x-axis because it's never pointing upwards, right? It'll just keep going down, 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 further and further, never touching the x-axis. In this case, you have 0 real solutions. All right? And that's just one way to tell how many solutions you have in a given problem. It could be 2, could be 1, could be 0. But this is one way, and the first way that we're introducing here is just by graphing. So when you graph these, you'll end up with a couple of solutions or something like that. And that's all they're looking for. Normally, my problem in textbook would be like, all right, well, I'm going to give you this graph, and I'm going to give you the graph. I'll give you this graph here, and then I'll ask you, what are your solutions? Well, your solutions are 1 and negative 1, or whatever I label these as. These points could be anything. They could also be a decimal, so they could be between 1 and 2, in which case you guess that it's between 1 and 2. I won't be asking for any exact answers just yet, so I'm not looking for you to tell me that it's like 1.6358. We're not there yet. Okay? So this is your entire job with using graphing to solve quadratics. Let me go ahead and raise that up and get it all on one screen. It's not quite all. There you go. Alright, so solving quadratics. Alright. This is just by using graphing. For those of you that use a graphing calculator or are allowed to use a graphing calculator, this is the ideal time to use it. You just type in your function, and then you'll get some kind of graph, and all you have to do is use that intersect search. And you're going to look for where it intersects the x-axis, and you'll have your answer. So you'd hit like intersect, and then you'd put a dot over here and a dot up here, and then it'll tell you whatever that point is. It might be 1.625 or whatever else. Okay, so this is how to solve quadratics by graphing. That's actually one entire lesson in your book, but I'm going to go ahead and move on, and I'm actually going to go ahead and cover, or at least I'm going to introduce the idea of solving quadratics by factoring. Okay, and factoring means we're just pulling out common factors in any given thing. So this is this entire page. Feel free to pause here. I'm going to move on to the next thing. Actually, never mind. That'll go ahead and be in the next video. I'll actually stop this recording, post this, and then I will go ahead and record another video that introduces factoring. Alright guys, so I will see you in just a bit.